Welcome back. Today we're talking about unit 1.5 about the complex numbers. So as we know, the quadratic equations, sometimes they have no real solution. For example, if I take x squared plus 1 is equal to 0, it doesn't have any real solution because no real number that can be squared to produce negative 1, because if you put x squared plus 1 is equal to 0, it is x squared is equal to negative 1, and I cannot square any number to produce negative 1. So mathematicians, they created a system of numbers using something called imaginary unit, and it is represented by lowercase I. Imaginary unit, and it is represented by lowercase I. So what is I? Let's understand it a little bit more. So whenever we have a negative number, we can substitute with I, because I is nothing but the radical of negative 1, or I can say I squared is negative 1. So I can replace negative 1 with I squared, or as simply as radical of negative 1 is I. If I keep on repeating the pattern again and again, you will see I squared is negative 1. What will be I cubed? I cubed is nothing but I squared times I. So it will give you negative of radical negative 1. Let's find out what will be I4. So I to the power of 4 is nothing but I squared times I squared. And I squared is negative 1. So negative 1 times negative 1 will give you only 1. And the same thing you can, same way you can calculate the others. Now when we are talking about the complex numbers, we are saying that the complex numbers, we get complex numbers by adding real numbers to real multiples of this imaginary unit. That is the basic principle of the complex numbers. Imaginary unit, which is nothing but I. Now, as with other functions and other numbers, we can, just like quadratic, the exponent, there is a standard form. There is also a standard form for the complex numbers. So the standard form of the complex number is A plus B I. So few things that are very crucial in here. When we are talking about A is just standing alone, right, without any imaginary numbers. So A is your real number, real part of the standard form. Now B, the term B has I, so that is the imaginary part, right? Makes sense because it is multiplied with I, and I is nothing but imaginary number. Let's take one example. So we have negative 4 plus radical negative 9. Till now we will say, oh, we don't have any real solution. But now we know the complex number, so we can rewrite it as radical of negative 1 times radical of 9. And what is radical of negative 1? That is nothing but I. Right? So we can solve this problem by introducing I, and so it will be in the standard form negative 4 plus 3I. So negative 4 is the real part, and 3I, because it is multiplied with I, that is your imaginary part. So whenever we have a negative, we can replace it with I. Now let's take few scenarios. What happens when B is equal to 0, right? Because in the standard form. So when B is equal to 0, then BI becomes 0. So that is nothing but a real number. So basically, you can write any real number in a complex form by putting B as 0. Isn't that interesting? Right? Let's take, basically it is just a real, every real number can be written as a complex number using B is equal to 0. because bi is your imaginary part. Okay, now what will happen if b is not equal to 0? If b is not equal to 0, then it's nothing but your imaginary standard form, right? So when b is not equal to 0, I can rewrite it as a plus bi, which is nothing but your imaginary standard form. Okay, let's build up on this. Now, if I write bi, provided b is not equal to 0, this is called a pure imaginary number, because there is no real number, right? So this is pure imaginary number. So if bi is standing on its own, for example 3i, 5i, without any other term, that is called a pure imaginary number, because it doesn't have any real number added or subtracted to it. Now we can understand the complex number. Complex number is a big umbrella. Under the complex number we have real numbers. We have already discussed what comes under the real numbers, and the another thing that comes under complex number is called imaginary numbers. So that is why the standard form has a real number and the imaginary part, a plus bi. So real numbers and imaginary number. So it is basically, it is a set of real numbers, and it is a set, is a subset of the set of complex numbers. So real numbers is a subset of the complex number, just like imaginary number is a subset of a complex number. So complex number is a big umbrella. Okay, how to represent it on a number line? So its graph can be graphed on a complex plane. So on the complex plane, the horizontal axis is nothing but the real axis. That means x-axis is considered as real axis. Now then, what is your imaginary axis? Imaginary axis is the vertical axis, or the y-axis is considered as imaginary axis in the complex plane. Let's graph few points. For example, if I have to graph 2 plus 3i, now remember 2 is the real number, so 2 will be on the x-axis. 3 imaginary, so it will be on the imaginary axis. So that is your coordinate. That is your, this is your complex plane. So to represent 2 plus 3i, we are plotting the point right here. So we can take other example also. Let's say -3, -i. Negative I is nothing but -1 times I. So -3, and on the y-axis, -1. So this point represents -3, -i. Okay. Now the theory part is done. Let's understand few important operations and properties of complex number. So two complex numbers, a plus bi, and c plus di, can be written equal to each other, or we can say they have the equality if and only if. So a plus bi is equal to c plus di only if a is equal to c and bi is equal to d. So b and d, they should be equal, and a and c, they are equal. So a and c, they are real number, and b and d, that is the imaginary part. Basically, we can do everything with the complex numbers. as we can do with the polynomials, right? So the operations will remain the same. Just treat them like a polynomial or like a variable. It is same for all the operations, whether it is the adding, subtracting, dividing, multiplying. Let's take few examples. Let's start with adding. So if I have to add two complex numbers, so the process is simple. I will add the real numbers together and we will add the complex numbers together. So basically combining the like terms, the same thing that we used to do for polynomials. So a plus c and then b plus d, and because I is the factored form, I will take the I out. Same thing with the subtraction. Let's subtract the two complex numbers. Minus c plus di. So combine the real numbers together, then subtraction. So a minus c plus b minus d, and I is right there. Let's take some examples. So we have these two complex numbers and they want us to add. So we can add 7 and 5 and then 3i and negative 4i. And I can put I outside the bracket. So that will give you 12 minus I. And that is your final answer. That's it. Just like combining the like terms. Let's take another example. Let's take three complex numbers and we will add and subtract them. Again, the rule is the same. Combine the like terms, combine the real part and combine the imaginary part. Five plus 3 minus 8, and then we have negative 3 plus 5, and then negative 2, and I will stand outside. So if you solve it, surprisingly, you will get 0 as the answer. Now I helped you with two questions. You try two questions for me before we proceed to the properties of real numbers and complex numbers. So these are the two questions. Give it a try. Okay. Let's move forward. Now let's talk about properties. So properties of real numbers are also valid for complex number. So when we are talking about the properties of real numbers, we are talking with respect to what we have done with the real numbers, just like associative property of addition and multiplication, or cumulative property of adding, addition and multiplication, or distribution property. So all the properties of the real numbers, they are valid for complex number as well. So nothing changes. Let's understand it with one example. So let's do multiplication. So remember, when we are multiplying the two terms in two different brackets, we are using distribution. So the same thing will go with the complex numbers. But something interesting will happen when you multiply the two complex numbers together, especially with the I. So we have 2 minus 4i and 3 plus 3i. So let's use distributive property. So I will take the first number, which is 2, multiply with the second bracket, 3 plus 3i. Take the second term, which is negative 4i, and multiply with the second bracket. Now 2 will be distributed with 3 and 2 will also be distributed with 3i. That will give you 6 plus 6i, and the another bracket will give you, that is this interesting part. So the last term is 12i squared, because 4i, negative 4i times 3i. And what we have learned so far, I squared is nothing but negative 1. So I can replace I squared by negative 1, and I can combine 6i and 12i together. And what is I? You are just writing it down. So it is 18 minus 6i, which is nothing but the standard form of the complex number. 18 is the real part and 6i is the imaginary part. Please try this question. I'm writing 2 questions. Give it a try. For the second one, use the property of a plus b whole squared. Alright? Okay. Let's continue. So the another thing in this chapter is called complex conjugates. So as you know from algebra 1, what is a conjugate? Conjugate, we only change the sign of between the two terms, right? If we have a plus b, the conjugate will become a minus b. That is the basic idea of conjugate. So the first thing that we are looking for in the complex conjugate is how to multiplying the conjugates together. So a plus bi will have the conjugate as a minus bi, and what will happen when you multiply with the conjugate? So if you clean this up using property, distributive property, you will get a squared minus b squared, I squared, and I squared is nothing but negative 1. So when we have a complex number and you are multiplying with the conjugate of that complex number, that will be nothing but a squared plus b squared. So this is a very handy identity, and you can write it down in your notes. And if you know this, you can quickly solve the questions without even doing the distributive property. So let's take one example. The question might say, write the complex conjugate. So when it says conjugate, that means you are multiplying the complex number with its conjugate. So it will be 3 plus 6i times 3 minus 6i, because conjugate means changing the sign of the term. And because we have just derived what will be the formula for this one, I can just say 3 squared plus 6 squared. And what is 3 squared? 3 squared is 9 and 6 squared is 36. And I think I wrote my answer wrong. I will change it later, but this should not be 21. This is 36 plus 9, which is 45. This should be 45. Now, the another type of question could be the quotient of complex in standard form. So, quotient, when we are talking about the quotient, that means we are talking something about px over qx. That means in a fraction form, right? So when we have two complex number in the fraction form, then we multiply with the conjugate of the denominator. So I can rewrite this as a plus bi divided by c plus di times the conjugate of the denominator, which is c minus di divided by c minus di. So multiply the numerators together and multiply the denominators together. When you multiply the denominators together, that is the same identity what we just did with multiplying the conjugates, right? So that you can rewrite it as c squared plus d squared. See the above property, a squared plus b squared. That is the same thing. So let's take one example. So we have 2 plus I divided by 2 minus I. I want you to try this question because you need to write in the standard form. Remember, you need to multiply with the conjugate of the denominator. So what would be the conjugate here? 2 plus I. Give it a try. And let's move on to the next part. And this is the final part because we will be talking about the complex solution of quadratic equation. So when we are talking about the quadratic equation, there are a few things you need to remember. If we have radical of a negative number, so I can separate a number times I, because radical of -1 is nothing but I, because I is nothing but radical of -1. For example, if we have radical of -8, for suppose, so I can write it as radical 8 times I, right? This is called principal square root of a negative number. Principal square root of a negative number. Okay, so there can be two types of question in this. So the first type of question could be, for example, they have given you two radicals that are multiplied together and they want you to write in the standard form. So they are asking you to write radical of -14 times radical of -2 in standard form. Now -14, what we just did, we can rewrite it in terms of I. So I can say -14 radical is nothing but, or we can multiply these two together first, whatever works for you. So we can either multiply -14 and -2, or that will give you radical of 28I squared. And what is I squared? I squared is nothing but -1. So we can say this is 28 times -1, which can be simplified in this way. Right? Now, I would like you to try a few questions for me, please. Okay, try these two questions. Question number A. Then B is this one. Give it a try. The second one, it has two terms. Okay, so the another type of question for the quadratic equations, it can be, they can say complex solutions of quadratic, and they want you to solve for this equation. So this is my quadratic. You can try to factor it out, or you can just use the quadratic formula. Quadratic formula is nothing but negative b plus minus radical of b squared minus 4ac divided by 2a. That will give you the x value. So we know what is a, b and c in the given statement, given equation. Let's plug everything back. So if I plug everything in the equation, I will get let's clean this up. Negative 14 plus minus, that will give you negative 96. Now we have a negative inside the radical. So when we have a negative, I can convert it into I, because radical of negative 1 is nothing but I. Now I can simplify it further. If you factor out 96, you will get 3 and 32. So I can separate them. So the standard form will be negative 7/8 plus minus radical 6, and I is outside the radical, and then divide by 4. Okay, I forgot to write plus minus, but it should be plus and minus. So this is the whole entire way of writing the complex number. The more you practice, the more comfortable you will be. Before we end this video, please write down this one last question and give it a try. And I will see you next time. Thank you.